啊，那讲真，这地方，一直高，我说我这个，这边有，刚刚有看好，在
刚刚那个宋老师拿去
那啥，我这边的话，我想然后这是现在，哎，这，对，好，
Ladies and gentlemen, dear guests on site and online, our conference will resume in 5 minutes. Please take your seats and mute and turn off your cell phones. Thanks for your cooperation.
So, do you want to have a quick check? Okay. So, actually, we will just leave this open because now it no no yeah that this is online meeting now.
Yes.
But this is yours. Already. Sorry.
You know.
Okay. Do you want to use the pointer for the speaker?
He'll be using for the 20 hours.
Okay.
Yeah, the laser.
It's work.
But he's only going
The laser, right?
it over, right?
Yeah. So do you have any video to play?
Oh, yeah.
Okay, please.
Maybe we try that. Yeah, it's working. Yeah.
Great.
Yeah, so we have others too.
Okay. Open your microphone online. Yes, open now. Okay. So if anyone pop up want to join that meeting, you can simply just accept that or you can ask our meeting. Yeah.
Okay. Message.
If there is a message, but probably not because I assume that the people.
Yeah, so if
I think
we have
this is the number. Yeah, I'll be here. Yeah. By the way, this is guys. Okay. I have several Korean colleagues in the same field. Yeah.
I'm okay. Ladies and gentlemen, dear guests on site and online, welcome back to today's forum. Our second keynote speech will be given by Professor Jun-Haenh Hall. Professor Hall serves at the Department of Civil and Environmental Engineering of Yonsei University. To acknowledge Professor Hall's solid knowledge and persistent commitment to the civil and environmental engineering community, Professor Hall was appointed as the president of Korea Society of Civil Engineers in 2022. The Korea Society of Civil Engineers, since its foundation in 1951, has promoted the development of civil engineering and the improvement of the quality of civil engineers for over 70 years. Professor Hall's keynote topic is Smart Technologies in Civil Engineering to Tackle Global Challenges. Please welcome Professor Hall.
So my name is Jun-Haenh Ho. It's very difficult to pronounce. So I would like express my sincere congratulations on the occasion of 50th anniversary of Chinese Institute of Civil and Hydraulic Engineering. And also I want to express very small thanks to President Song for the 7 shot of Gaoliang last night. And also, I'm looking for the Amar Batar, but I cannot find him. He's a president base. He gave me the 5 shot of Mongolian vodka last night. So I want to try one more time, but not the night, just before morning presentation. Maybe next time. Okay. So my topic is smart technologies in civil engineering to tackle global challenges. So I want to express special thanks to the Korea Express Corporation and K-Water because they supply some materials and videos. Okay. So let me introduce KSCE very briefly. KSCE was established in 1951 during the Korean War, And then we have more than 29,000 members and 11 regional sections and 75 committees and 80 domestic MOU organization and 28 international AOC societies and institutions. The here is a March, every March 30th, we celebrate the Civil Engineers Day. From history, March 3rd in 1398 in lunar calendar, the castle of Seoul was constructed. So 600 years later, the KSC established, set up this date as Civil Engineers Day. Okay. And also we every October we have a convention, especially year 2025. We plan to hold KSC convention jointly with CICHE in the Jeju Island. So the most beautiful island in the world. So I hope to see you all in there in 2025. I'll check your face, okay? And then there's a so-called Vision 2050 Center, and then they set up the vision, case vision. Vision is to share sustainable development and improvement of quality of life with the public based on the knowledge, experience, and competence of civil engineers. So there are three goals. So we try to achieve our vision, our missions. Okay. So let me emphasize the theme of CICHE 10. Okay. Uh, which is smart in civil engineering. Here is a SMART stand for sustainable management and resilient technology. Okay, so I think smart technology is a core element to achieve our vision and mission. So educating these technologies to young generation is very imperative. So nowadays, let me discuss why is that. Okay, there are many global challenges that faced by us, not only us but also all the country in the world. So one of them is a rapid urbanization and aging of civil infrastructure. So nowadays, many cities they are rapidly expanding. However, the safety of urban infrastructure also can be degraded. So there is an accident in my country. So here is there's a collapse. The sidewalk of Jeongja Bridge is the name of the bridge in the Bundang New Town. Bundang New Town is just below the Seoul metropolitan. This bridge was collapsed on April 4th. So cause of two casualty. This bridge was built in the just 30 years ago. And there is 164 bridges in the first generation new town project. These bridges are built in the similar period. So after collapse of this bridge, the public and government they concerned about this one. So now KSC is carefully investigating the cause of this collapse. And then see this figure here. So this figure shows the ratio of the infrastructure which are more than 30 years after construction. So in 2019, the percentage is 16.66, but just 20 years later, this ratio will be rapidly increased up to more than 70%. That's very severe, right? So as well as South Korea, now the many cities in the world, they are also facing similar problems. So you have to incorporate smart construction and maintenance technology that utilize the IoT, AI, big data, and other advanced smart technologies. This is very important, okay? So there is another one, another challenge, maybe global. Oh, sorry, it's a global climate crisis and the more extreme event, right? So nowadays, many countries, including the South Korea and recently the Libya, we are facing the climate change. So one of the noticeable consequences of global climate change is more frequent and intense climate events are expected, right? So there is another one here. There was a heavy, serious urban flooding in Seoul, main area of Seoul, so-called Gangnam. It's a well-known from the song of the Gangnam Style from Psy. This area is very expensive area in Seoul. This area was flooded. So at the time there was 8 casualties, and then from the record, the hourly peak rainfall intensity was 141.5 millimeter per hour. So this is bigger than 200 return period, and also it's much greater than the design drainage capacity of 95 millimeter per hour. This intensity is equivalent to the 30 years return period. So finally, Seoul city government, they planned to construct deep underground sorry, I'm not good. I'm sorry. Rainwater tunnels in 6 flood-prone areas, and also they increase the design return period up to 200 years. So now we manage the climate change, right? And then due to the climate change, the flood and drought are recurred almost every year in South Korea. So there you can see here the flood and typhoon means a flood drought. In 2012, there is a drought in all country of Korea, and then drought and typhoon and torrential rain and something like that. And then finally, last year, the severe drought in spring and severe flood in summer occurred in just 1 year. That's very serious problem. And then this year, just 2 months ago, right, there was a heavy torrential rain in South Korea. So it was reported 47 people are dead, and then 35 injured, and the 3 people are missing. It's terrible. And and then there's a very terrible casualty happened in the so-called Gungpyeong-2 underpass. It's this one here. So this underpass has 4 lanes, and the length is 685, with a 430-meter underground tunnel here, right? And then one of the banks of Mio River is very not the small, but it's controlled by the local government. Is beside the underpass, maybe around the 400 to 500 meter away. This bank was collapsed at 8:30 a.m. on July 15th. It's a Saturday morning. Then over 60,000 tons of mud water rapidly flow into the tunnel just in 2 to 3 minutes. So in this picture, Bio River is in this side. You can see the mud flow into the underpass, right? Just this is fully filled just within 2 to 3 minutes. So this is a CCTV captured image. You can see this is almost 5 minutes after the collapse of bank. Okay. Then you can see the red one and the white one. Red one is bus, and the white one is a truck. The bus and truck are being swept back to the tunnel. Actually, the bus and the truck was here, but because of this inflow, it back here, and then the next now the government they try to pumping out the water all the night. This is the next morning, Sunday morning. You can see the bus and the truck. So anyway, it's due to the climate change, but there is a man-made mistake. So okay, so it's terrible. And then everybody knows sustainable development goals, right? There are 17 goals, right? And then here the SDG 6, 9, 11, and 12, and 13 are closely related to the civil engineering. In particular, target 9.4 here is upgrade our industry and infrastructure for sustainability. So target 9.4 calls for building resilient infrastructure and promoting inclusive and sustainable industrialization and fostering innovation, which is quite significant challenge to us, right? To achieve target 9.4, we need innovation and technological investment, and I hope the collaboration of the ASEC members and the interdisciplinary approach are required. Okay, so we need more collaboration. Okay, and then the everybody knows smart technology will be core player in civil engineering in the future, right? So let me show two examples of how the to tackle global challenges with smart technology in South Korea. Let me show two examples. The first one is a smart construction R&D project. It's led by Korea Expressway Corporation. It's starting from the 2020 to 2025 for the 5 years. And the research fund is approximately 160 billion US dollars funded by Ministry of Land Infrastructure and Transport. So the main aim is to achieve productivity and digitalization improvement more than 25% and the reduction of construction period accident rate more than 25%. So actually this R&D project focus on the road sector because it's a highway express, okay? And then another one is a digital transformation in water management. It's developed by K-Water. K-Water is a public company which has authority for the national water resource management under the Ministry of Environment. Okay, and then the purpose of this project is to establish a new innovative water management platform to improve the efficiency of dam operation, decision making, and prevent water disaster. Okay, let me explain this one. So this smart construction R&D made by Dr. Sung Min Cho, he's over there. Please stand up. He controlled big project. He's also committee chair of TC30, right? Okay. And then 131 organizations with more than 1,000 researchers involved in this project. Okay. And then there's I'm going to show some videotape. What's a smart construction? This is prepared by the Korea Expressway Corporation. Around the 4 minutes. So this smart construction R&D is composed of 12 projects for the 4 core areas. The first area is earthwork automation and site data collection. And second area is prefab, DFMA, and structure automation. And the third one is smart construction safety. And the last one is a data and digital delivery platform and test bed. So there are 29 technologies, including 140 component elements. So let me briefly explain this one. So first area, they are focused on the earthwork automation and the site data collection. So the main purpose is to develop technologies by integrating the site information acquired through autonomous measurement using drones, unmanned ground vehicles, and various scenario sensors. Okay. And then there are 3 specific projects. The first one is intelligent control of construction. Second one is collection and analysis site information. And third one is digitalized automation of construction equipment. So we hope to improve the productivity of earthwork for those construction more than 25% after this project. Okay. And the second one is the prefab, DFMA, and structure automation. So in this area, we want to develop technologies that employ BIM, AI, 3D scanning, prefab, and robotics to improve the design, fabrication, construction process. Okay, and another one purpose is to develop the remote control automation technology. And then there are also three specific projects. The first one is BIM-based support of design, fabrication, construction for prefab. Second one is remote control and automated construction for bridges and tunnels. The other one is quality control for prefab. So in this area, we want to reduce the construction period more than 25%. And the third one focuses on the smart construction safety because nowadays safety is very important in my country. So there are three specific projects. One is the integrated system for smart safety control. Second one is a securing safety for construction workers. Third one is a safety measures for temporary structures. So through this project, we want to reduce the construction fatality more than 25%. Okay. And the last one focus on the data, digital delivery platform and the test bed. So in this area, we want to develop technology for provision of information and the services appropriate for digital platform users. Also, we want to construct a comprehensive test bed to verify the developed technologies for each sub project. Also, there are three specific projects. The first one is a data integration, smart delivery, and knowledge-based measurement. Second one is a digital platform and virtual construction using digital twin. And the last one is a test bed demonstration. So we want to improve the digitalization in the construction process through this project. So there are several videos, but because of time, I'm gonna show the last one. Okay. Okay, this is for the smart construction R&D project. And then, as I said in the introduction, now there's many countries, including the United States, the climate change. So I'm going to show one more example. This is digital transformation in water management. It's developed by K-Water. So let me explain this one. So to overcome new normal climate change and then to reduce the risk of innovative approach to counteract climate change through digital. So one of the key technologies of digital transformation is digital twin. So maybe last year, the digital twin was selected as the key policy in the Korean version of a New Deal project. So now government they very concerned over this one. Okay, so there was a massive flooding in downstream of areas of Yongdam, Somjin River, and Hapcheon Dam. These three are multi-purpose dams controlled by K-Water. But anyway, there is some kind of a longest rainy event for 54 days and heavy torrential rainfall. So the K-Water released the water based on their manual. But however, there was a flooding in downstream. So eventually, K-Water paid several hundred million US dollars for the flood damage compensation. But I don't like that. But anyway, the government they push to K-Water to pay some money. It's very, very bad case, okay? And then now the K-Water try to develop a system, so-called digital twin, okay? So in 2021, they developed so-called a pilot platform for the Somjin River Basin. And then now then they have upgrade and expand this digital twin for the 5 river basin, okay? So the digital twin is a cyber physical system that synchronize the real world with the cyber world, right? So using various data in cyber world, the user can find optimal operation rules by monitoring simulation and prediction in the cyber world. Then this solution can be fed back into the real world. Okay. So, okay. 뭐한 거지? I think the file is too big. So sometimes it's very slow. I know what. It's stuck. Sorry, it's a stuck. Yeah. So the goal of this project is to establish new innovative water management platform to improve the efficiency of dam operation. So the spatial scope is 5 major basins. There is a Han River Basin, Kumgang, Nakdong, Yongsan, Sumjin River Basin. That's 5 major river basins in my country. The total area is 67,000 square kilometer. So it covers around 70% of total area of South Korea. Okay. And then the technical platform. So the monitoring and fraud platform are already developed, and the rest of them are under development. And then this slide shows web GIS-based digital twin platform. So this is connected in real time with various geospatial and water-related data. Okay, and then this platform include the 3D map, GIS function, manipulation, saving, layer control, system management, etc. And then finally, this web GIS-based 3D map provide not only 3D visualization, but also two-dimensional table and graph. And then this slide show how to make 3D digital topographic map, which is the foundation of the digital twin platform. So here, the bridges, objects such as bridges, can be produced using the drone mapping, And here is a high resolution DTN for the reservoir or riverbed can be obtained using the multi-beam echo sounder. And then finally, the 3D base map can be obtained by merging orthogonal image with the DTN. And this is the 3D visual world. This is Seoul, So Yeouido area here. This is a Han River. It's very high resolution. So they have a view in the urban area in the BI. They so-called level of degree is 4, and the rural area LOD is just 1. Two. This is a Han River. I live in the here. My home is just up here. Okay. Okay. And displayed on the smart big board and the K water integrated control room. So you can see the very small computers here, personal computer. So this platform can be used by individually using the personal computer. So maybe the guys in here, they type and everything, right? And then this show the demonstration video for the Garam, the digital team platform developed by the K Water. The UI user interface emphasize the 3D object then and here, and then also you can investigate the flood result, and then you can also monitor salinity by modeling in the river estuary. Because in my country, three sides are exposed to the sea, right? And then this is a simulation platform. This is the core of this platform. So there is a 2D flood simulation in the river basin and the urban area can be done based on the WebGIS and game engines. You can see here, this is a flood simulation Samji River, and there is also flood simulation Samji River using the game engine. And this flood simulation Kum River is another basin, and the flood simulation in urban area. This and the K-water use a so-called cost film for the modeling, and also the user can upload and check the simulation result, and also user can check the summary board here. So you can see just in the control room, and then maybe you can simulation, and then checking, and then maybe feedback, and then everything controlled by this control room. Okay. This is how to decide dam operation. So first step is rainfall forecast. Second one is analyzing dam discharge. Third one is checking the constraint, dam constraint. The fourth one is modifying dam release. The final one is rechecking the constraint. Actually, there is some kind of example video, but the voice is not good, so I'm gonna skip this one. Okay. But this lady is audio recording is not good. So this is the final conclusion. Okay. Uh, uh, I briefly interest how Korea is preparing future with the smart technologies. I just explained just two examples. One is a smart construction R&D. The other one is data twin management and water resource management. Okay, so this national R&D program led by Korea Expressway Corporation, the Dr. Cho, and another one is a data twin platform developed by K-Water for managing water and climate disasters. Because in 2020, there's a big flooding, so K-Water they paid several hundred billion US dollars. So now we need some new one, right? We need that. So they developed this one. So uh, as you know, the smart technologies help agile decision making based on the reliable data and can reduce the risk in our lives, right? Also, I believe that the smart technology will make us live in a better future. Everyone believes that. But I want to emphasize that these smart technologies are only auxiliary device. So if we can get many benefit from these excellent smart technologies, we should not forget that the proper decision should be made based on civil engineers' expertise. In other words, our expertise, right? With a solid foundation. Thank you. 谢谢.
Thank you, Professor Hall, for the great sharing. Is there any questions for Professor Hall? So let's give a warm applause for Professor Hall. So today's third keynote speech is given by Professor Song Yuqi. Professor Song is a distinguished professor at the Department of Civil Engineering of National Taipei University of Technology. With Taiwan Highway Bureau and China Engineering Consultant Incorporation. Professor Song